Hey everyone, in this video we are going to discuss the LeetCode contest, that is biweekly contest 183. And this I had a look at the problem set of this contest, and the problem set is quite interesting. And some of the problems in this, one of the problem in this contest involves DP on trees, and one of the problem requires you to use the Kidding's algorithm, right? So if you're someone looking forward to learn DP and data structures and algorithms on trees, you can give this contest. And you can, if you are stuck somewhere or you are not able to solve any of the problems, you can see this video, and after watching the editorial in this video, you can yourself try the problems. So without wasting much time, let's dive into the problem set. Here is the first problem: minimum swaps to move zeros to the end. So you are given an integer array, and you can make some of the operations. In one of the operations, you are given two indices. You can take two indices which are distinct and swap the elements corresponding to these indices. Now your target is to move all zeros to the end of the array in minimum number of operations, and you need to return these minimum number of operations. Okay, so if we take the first sample test case, here what we can do is we can simply, so our algorithm for solving this problem will be, we will iterate over this array. Wherever we find the 0, we will try to swap this 0 with a non-zero element which is farthest from this 0, right? So here in this case we have 12. So in the first operation, what we will do is we will swap 0 with 12. So here is the updated array 1 0 3 0. Okay, now this is 12. Okay, so let's move to the second index. This is non-zero, so again this is 0. So we will swap with the farthest non-zero element on the right side, right? So here it is 3. So let's swap in. So after second operation, the array will be 12 1 0 12 1, and in this place it will be 3 3 0 and 0. So now we have moved all of the zeros to the end of the array in two operations. So our answer for this test case will be 2. For the general array also, we will do the similar thing. We will iterate over this array from starting to end. Wherever we find a 0, we will try to swap this 0 with the non-zero element which is farthest on the right side. So let's implement this algorithm. First of all, we need to count the number of non-zero elements in this array. If u is greater than 0, count plus plus. Let's take a variable to store the answer and iterate over the elements of this array. If this element is 0 and we see that there is a non-zero element on the right side of this, then we will swap this 0 element with the non-zero element which is farthest from right side, right? And we will decrement the count of non-zero by 1 because we have swapped it. Else, if this element is non-zero, in this case we don't need to swap, we just decrement the counter of this non-zero element by 1 because we do not need to swap this. At the end, just return the answer. So for our first sample test case, answer is 2. Okay, 1 and 1. For second one, 1. For third sample test case, our answer is 0. Okay, let's submit it. Great. So let's move to the second problem. Here is our problem. The problem is that you are given an integer array nums, and you are also given an integer array you are also given an integer k. In one operation, you can either decrease or increase an element by 1. At the end, you need to make the array modulo alternating. And now what is modulo alternating? You take you take two distinct integers x and y, right? Between 0 to k, 0 inclusive. And for every even index I, you will make all the element mod k equals to x. Similarly for odd. You need to calculate the minimum number of operations required to make nums modulo alternating. Okay, let's see the constraints. The number of elements are order of 100. Value is order of 10 to the power 9 and k is order of 100. So let's take the example of first sample test case. How do we go about solving this? So first let's extract out the elements at odd indices 1 and 2, and these are the elements at odd indices, right? Let's also extract out elements at even indices. These are 4, 8. These are elements at even indices. Now we need to make these elements equals to x and these equals to y such that x not equals to y. So one thing we can simply do is for first these odd indices elements, what we can do is we can just increment the first value in one operation. It will be 1 plus 1 comma 2 equals to 2 comma 2. This will require one operation. For this one, and here in this case our x is 2. For second one, first let's take modulo. After taking modulo, the array becomes 4 modulo 3, 1, 8 modulo 3, 2. Now apply one operation, that is decrement 2. You can see that if we apply an increment operation at first element, it will become 2 comma 2, and here also y equals to y will be 2. But in the problem itself we see that x and y must be distinct. So in this case apply a decrement operation at the second element. So the array will become 1 comma 2 minus 1, that is 1 comma 1, and here ry is 1. And as x and y are different, it also took one operation, and as x and y are distinct, our answer for this will be 1 plus 1, 2. 2 is our answer for this sample test case, and this is correct also. Okay, so for a general array, let's take a general array a equals to a1, a2, a3 up to an. Let's calculate its a dash array, which is module, by taking mod k. So it will be a1 mod k, a2 mod k up to an mod k. Now our a dash array is converted to a1 dash, which is equals to a1 mod k, a2 dash, which is equals to a2 mod k. Similarly an dash. Now we will do similar thing here. We will extract out odd indices elements and even indices elements. Let's take odd, odd indices elements, which will be a1 dash, a3 dash. Even indices elements a2 dash, a4 dash. Now we see that we have k between 0 to 100, so we can just brute force over elements of x, right? we will try to make all the elements of this odd indices equals to x, and we will just iterate x from 0 to k minus 1. And similarly for all even indices elements, we will try to equate equals to y, which, and we will also brute force y from 0 to k minus 1 because k is small, so we can just brute force it. And let's say it took uh, op1 operations and it took op2 operations. So for this particular case, our answer will be op1 plus op2, right? Total number of operations will be op1 plus op2. And we will, as we are brute forcing over all values of x and all values of y, we will take minimum of total operations for any of the value, right? So, and that will be our answer, minimum over all values of x and y, right? Minimum operations over all value of x and y, we will take the minimum. And we will also need to take into account that x and y must be distinct for okay, so if x and y are distinct, only those operations we will take into account and take minimum of those operations, and our answer will be the minimum value. Let's implement this solution. So take a variable answer, and answer, let's initialize with it maximum value 10 to power 9, because obviously our answer will be less than or equals to n into k, right? So let's, and 10 to the power 4, so let's take a big value, that is 10 to power 9. Our answer will always be less than 10 to power 9. And now iterate over all the values of x and all the values of y. Okay, now if x equals to y, just continue. We do not care, we don't take these operations into account, right? Because problem is given that, in the problem it is given that x and y must be distinct. Now let's calculate the operations required to make all the odd indices elements equals to x and all the even indices elements equals to y. First of all, let's calculate the a dash array, that is take modulo for all the elements of nums array, take modulo k. Okay, once we have taken modulo, we get this a dash array. Now just simply try to equate all the odd elements equals to x and all odd all elements which are present at even indices equals to y. So first iterate over the odd indices. Okay, now let's say if this element is greater than x, so as this is we are iterating over odd indices, we are trying to equate this element equals to x. So let's say if this element is greater than x, one thing we can do is we can decrement this value, right? We'll take minimum. I will explain which two values we need to take minimum. So we have two options. What are those two options? Either we can decrement this nums value. So if we decrement, how many operations we will require to make nums of I equals to x? Nums of I minus x, right? Another possibility is either we can increment the value of nums such that at some later point, if we take nums of I mod k, it will be equals to x, right? So how many operations we will require to make nums of I mod k equals to x such that we increment this value? The number of operations will be k minus nums of I, right? These are the operations we need to These are the operations which are required to make nums of I equals to k. The extra increment we need to make is x, right? Why? Because at this point, after applying this point, nums of I is equals to k, right? So if we take mod k, it will be 0. So the extra number of increment operations we need to apply on this element is x. So the total number of operations applied, increment operations we need to apply on this nums element, such that its nums of I mod k equals to x will be these. So these are the increment operations we can apply, and these are the decrement operations, and we will take the minimum of both of these. The another possibility is that nums of I is less than or equals to x. In this case, similarly, our answer will be minimum of either we increment this or we decrement this value. It will be nums of I plus k minus x. Okay, this is for the odd indices. Similarly, iterate over the even indices, and similar thing we will do here, but for y. Okay, at the end just return the answer, and also here minimize the answer. Let's define an why why is it -1? We made a mistake somewhere. Nums of I is greater than x, then the operations will be these. This is true. Okay, if nums of I is less than x, then this is true. If nums of I is greater than y, then nums of I minus y. Oh, this is y. First one answer is 2. For second sample test case answer is 1. Okay, let's submit it. Great. So let's move to the third problem. Our third problem is maximum path interaction sum in a grid. You are given a matrix. You are given a grid of m cross n size. Okay. Two players move across the grid. Player 1 starts at this point. They will move either right or down. Okay, either right or down, and they will move up to index this. Player 2 starts from bottom left, this index, and can move only right or up. Their destination is the top right cell. Okay, this cell. Each player must choose a valid path from their respective starting cell to their destination. Okay, a cell is shared. A cell is called shared if it belongs to both chosen paths. Return an integer denoting the maximum possible sum of values of all shared cells. Okay, Great. So let's see the pattern of how the shared cells will look like, right? So if we take an example of this matrix itself, can we copy this? Okay. For the first player, let's say he moves like this path the first player takes. The second player can take either this path. In this case, the total number of shared cells are these 2, -1 and 3. Right. So another path the second player can take is if they take this path. In this case, the shared cell is let's remove this. So let's draw it in some other image. Okay, let's say take the first player takes this path. The second player can take this path. In this case, their shared. Okay, let's take the shared. The shared cells are 2, -1, 3. In this case, the shared cells are only -1. In this case, also take another example. Let's take the first player takes this path, the second player takes this path. In this case, the shared cells are 1, 1, -4. So if we observe this pattern a little bit more, what we see is can you can only take either horizontal rows, right? You can either take a horizontal path, shared path, or you can take the vertical path. Let's take any path they can take. Let's take this. So either horizontal path or vertical path can be shared. These two players cannot choose any zigzag path. If you will notice the pattern. So for this case, let's say how they can choose this shared path. This is simple. First player will start from here. They will go across like this. Second player will move like this. So this is the shared path. How can these players take these three cells as the shared path? Simple. The first player will can move like this, and the second player can move like this, this. Simple. So this in this case, this is the shared path. So what we observe is either horizontal or vertical is the shared path. Now one another thing you need to notice here is that you cannot that for the all of the corner cells, let's take अगर आप कॉर्नर सेल से स्टार्ट करते हो अपने पाथ को, then you cannot choose only one of the cells. Let's say you cannot take this as the shared path. Try different ways. You cannot take only this shared path, right? Let's try to make such a path. So for example, let's take the first player move like this. The second player will try to go to this path, go to this cell. Then how will the second player move? Either this or second option is either this. But notice that in both cases, this is not only the shared path. In the shared path, this cell also come automatically. In this case, this cell would come automatically. So you notice that if you want to take a cell which is present at the border of this grid, right, which is border I'm talking about. So if you want to take any of the border cell, these all are the border cell. If you want to take any of the border cell, then you will have to take one another adjacent cell also, right? Because we can notice that if you you yourself try to choose any of the border cell, then you will notice that you will have to take at least two adjacent cells, right? Let's say if you want to take this cell, then either you will have to pick this adjacent cell in the shared cells, or this. So our problem comes out to be, first of all, ignore the border cells, right? Then you can choose any of the vertical segment, and the segment can contain any number of cells greater than 0, either 1, 2, or 3, right? You can take 1, or these 2, or these 3, or horizontally also similar thing. You can either take these or both of these, है ना? Another case is the border cells. Let's say you are taking into account the border cells. In this case, you will have to take at least two adjacent cells. So let's say you want to take this one into account. Then you will have to take either this, or this, or this, right? This is a possible valid. Or let's take you are taking this. There is another possibility is either you will have to take both of these, or three of these, or four of these. But you can't take only one of the border cell, right? You understand, right? If you are taking any of the border cell, you will have to take one another cell which is adjacent it. At least you can take more than one, but at least one another cell you will have to take. Now our problem becomes simple. What we need to do is, let's assume we are given these arrays, right? These horizontal arrays. We can apply Kidane's algorithm to select a subarray which has the maximum sum, right? Similarly, we will run a Kidane's algorithm over the vertical arrays. Let's assume these are the vertical arrays. Let's run a Kidane's algorithm over this array, over this array, over this array, and over this array, and calculate the maximum possible subarray sum, right? So let's implement the solution. This implementation is quite easy. The number of rows are okay. Let's take an answer which represents maximum possible sum. Right. These values are -100 up to 100. So let's initialize it with -100. Okay. Because the answer cannot be less than -100, we can just pick one of the in between cells, right? And n are order of 1000. So answer cannot be less than -200, because we can just pick two cells. It is also possible that, right, it is also possible that there are four cells, only four cells, n is equals to 2 and m is also equals to 2. In that case, if we pick any cell that will be border cell, then we will have to take an adjacent cell also. So our answer can not be less than minus 200. So just initialize our answer equals to minus 200 and let's iterate. So for the first case only, we are not taking into account border cells. We are only taking into account the inner cells except the border, right? So just iterate over the matrix and do not take into account the border. Iterate over the rows from 1, 2 and minus 2 also similarly. Now for this array, now for this row, we are horizontally going to apply the cadence algorithm over this row. So let's initialize the sum equals to 0, j equals to 1 to m minus 1, sum plus equals to grid of ij. Okay, and our answer equals to maximum of answer comma sum. If sum is less than 0, we will just simply assign sum equals to 0. Great. Similarly, this is the horizontal view of all of the arrays. Let's also consider the vertical view. So j equals to 1 to j up to a minus 2. Now iterate. So now we will iterate over this we will iterate over this column, jth column, and apply cadence algorithm over this column. I equals to 1 up to I less than n minus 1, I plus plus, define some variable, do the similar thing, sum plus equals to this. Okay, our first case is covered. Where we have taken the inner cells, that is except the border cells, into account. Now let's also take into account the border cells. Similar thing we will do. We will iterate over, in this case we are iterating over okay, in this case we are iterating over all of the rows from 0 to n minus 1. Okay, and we will iterate over all of the columns from 0 to m. The only difference is we will take at least two cells into our subarray. How we can do this? Let's take the first cell initially. This is 0 and start from the first index. Take into account the second. Maximize the answer. If sum is less than this current index, simply assign. Similar thing do here. What we need to do is start from, in this case we are iterating over vertically over all of the columns, and also we are taking into account the border cells. Take grid of 0 comma j. Okay, and now iterate over 1 to n minus 1. Take into account this value. Maximize the answer. If sum is less than this grid, at the this is our, at the end our answer We have already calculated, just return the answer. Let's try it out on the sample test cases. For first sample test case, our answer is 4. Output is 4. Okay. For the second sample, our answer is 3. For them also 3. Let's submit it. Great. So now let's move to the third problem. Actually, I like these two problems, the last one and this one. This is also a good problem. So let's read it out. You are given a rooted tree with n nodes labeled from 0 to n minus 1, represented by an integer array parent of length n. So okay, you are given a parent array, and you are also given an integer array nums of length n, where nums of I is the value of node I, and you are also given an integer k. So let's define a non-empty subset of nodes is valid if the sum of the values of the nodes, selected nodes, is divisible by k. Okay, and no two selected nodes are adjacent in the tree. Okay, now your task is to calculate the total number of valid subsets modulo 10 to the power 9 plus 7. Okay, if we see the constraint n is order of 10 to the power 3 and k is order of 100. So if you see from the problem statement itself that your you have said that two nodes in the tree cannot be adjacent, right? So if we see this carefully, we it is so if we see this carefully, what we can do is we can take two DP arrays, right? One DP array is that it will take into account all of the subsets in which the ith index is included, right? Another DP array is it will store all of the number of subsets in which the ith node is not taken into account, right? So to better visualize this, let's take into account of any subtree. Let's draw it here. Okay, let's say we have this tree. Make any random tree. One is connected to 3. This is 5. No, let's take 2. 2, let's say these are 4, 5, 7, 6. Okay, let's say we have this tree now, and also take the values k. Let's take k equals to 3 for simplicity. Let's take the values. This is node 1 has a value 0. Let's say 2, 1, 1, 2, 1, 0. Is 0 assigned? No, these values are from 1 to 10 to the power 9. So let's take, instead of 0, let's assign 0. Let's assign 1. This is also 1, let's say. And let's say this is 2. Okay, we need to calculate the total number of subsets we can choose from this tree such that the sum of the values of all the nodes in the subset mod k equals to 0, right? And another condition is that we cannot choose any two adjacent nodes in the subset. Okay, so what I'm saying is we can try to solve this using DP, right? So for each node let's say for each node we will store two values. What are these values? dp of, let's say, sum, comma, this is sum, and this is let's say zero, and also take another dp, let's say sum, and let's take 1. Now for each index we are storing these two values. This is sum, right? And sum below this is sum of nodes in the subset modulo k, right? And right, so s represents sum of values of nodes, right? Sum of values of nodes modulo k. So this represents total number of subsets total number of subsets whose sum modulo k is equals to s, and the value of node is not selected, right? And what does this represent? dp of s comma 1, it represents total number of subsets whose sum of values mod k is s, and the current node is selected, right? Current node is selected into the subset. So let's say once we calculate these values for each node, what will be our answer? Our answer will be dp of, our answer will be dp of 0 comma 0 plus dp of 0 comma 1. This will be our answer. Okay, and for simplifying the solution, we initially we will take into account that we can select an empty subset. So for the empty subset, we will so the contribution of empty subset will be into this array, not this array. So because we are not selecting any element, and we will initialize this dp array, dp of 0 0 with 1. Okay, dp of 0 0 with 1, because we are taking into account the empty subset. So our final array, this will be also having the empty subset, and in the question we are given that we do not take into account the empty subset, only we need to take non-empty subset. So we will remove -1 from here. So this will be our answer, final answer, dp of 0 0 plus dp of 0 1 -1. Now to understand it more clearly, let's implement the solution first, right? And see how we can merge the solution from the child to the parent, right? So let's implement the solution here. First of all, let's calculate the adjacency list. uh, First, total number of elements in this trees, total number of nodes in this trees, n, that is parent size. Okay, now let's make a adjacency list. Once we have adjacency list, now what we need to do is Let's create a dfs function. Let's also create a dp array. Dp of n comma dp k or vector 2 comma 0. Now let me explain what does this store actually. So dp of I j k, k holds only two values. Let's define it separately. Dp of I j 1. Okay. Now what does this store? It stores the total number of subsets whose sum mod k equals to j and the node I is not selected into these subsets. Okay. Now what does this dp state store? This dp state stores the total this dp state stores the total number of subsets whose sum modulo k equals to j and node I is selected into these subsets. Okay. Okay. Now let's implement this solution. Create a dfs function. Dfs. This is, let's take s is the current element which we are traversing. Okay. So initially we will assign for this element, for this node s, let's initialize this dp of s 0 0. This is, we are taking into account the empty set, right? And let's also assign dp of nums of s mod k comma 1 equals to 1. Okay. Now let's iterate over the child of s and go deep down the childs, right? And now let's calculate all of the dp states for this node s. Okay. So we will iterate over all the states of child u, right? And we will add, we will try to, so here we are trying to do dp merging, right? We are trying to merge the dp states of child u into the node s, right? So how we can merge is, so let's first define a temporary dp array to store the merging state. This let's say new dp. Okay, it will be initially all the values will be 0 in this new dp, or let's say temporary, let's temporary dp. It will store the current dp state, right, which we are going to merge. Let's iterate over the dp states of child element u. We will try to merge each dp state of child with the each of the dp states of the parent, that is s. So here in this case we are merging child state I into the parent state j, right? So what does this mean? dp of sj, 0 will calculate 0 will store the total number of subsets whose sum mod k equals to j, right? And the current node is not selected, right? So now as we are going to merge dp state dp of u I and 0 into the parent, what does it mean? It means that the child node is not selected, but the sum of the nodes in the subsets of child u is equals to I, right? So now what will be the sum modulo totals if we are merging the state I into state j? What will be the, let me say, what will be the sum modulo? It will be I plus j. We are going to, so to be clear, we are going to merge the child state I to the parent state j, so their total sum is this. Okay, and if we are not considering the current node value, then our answer will be this plus, now here is an interesting thing. Let me first implement, then I will explain the merge. Okay, so the total number of, if we are not taking into account this parent value, then we can take into account the child node value, or we do not take into account the child node value. So the total number of possible subsets here will be dp of u I 0 plus dp of u I 1. Okay, because we are not taking into account the parent value, so child value we cannot take or we cannot take, because the both adjacent will not be selected either way, into, right, total number of ways is चाइल्ड में से किसी एक सबसेट को ले लिया इनटू पेरेंट में से किसी एक सबसेट को ले लिया, दैट इज एस जे 0 mode. Also define a mode here. Okay, similarly also calculate the state where we take into account the parent value. In this case our value will be, merge state will be, value of merge state is so let's say if we are taking into account the value of node s, then the only possible way is that we cannot take into account the value of child node, right? Because let's say if we take into account the value of child node, then we will have two adjacent nodes selected, right? But we don't want that. we cannot take two adjacent values into our subset. So here this one means that we are taking into account the value of node S. In this case, the total number of ways to select from the child is only from this state 0. वन स्टेट वी कैन नॉट टेक इनटू अकाउंट. क्यों? क्योंकि हम चाइल्ड नोड को सिलेक्ट नहीं करेंगे इस बार, क्योंकि हमने पेरेंट नोड को ऑलरेडी सिलेक्ट कर लिया है. सो दीज आर द नंबर ऑफ वेज टू सेलेक्ट वन सबसेट फ्रॉम चाइल्ड नोड. नाउ द नंबर ऑफ वेज टू सेलेक्ट one subset from parent is this. Okay, so these are the merge states we have calculated. At the end, after calculating the merge states, just assign these states to the parent. Okay, our answer will be 0, 0, 0 plus TPO 0, 0, 1 minus 1, because we don't want to take into account the empty subset, plus mod. Call this DFS loop from the parent 0, from the root 0. Okay, so let's run this. For the first case, the output is 1. For the second sample test case, our answer is 2. Okay, so let's submit it. Great, it worked. So there is only one thing that you might stuck on, that is how this merge happened here. So this is simple. I had also explained while implementing. Let me explain once more. So इधर हम क्या कर रहे हैं ना कि हमें ये वाली स्टेट कैलकुलेट करनी है, राइट, दिस डीपी ऑफ एस की, राइट, एस नोड की हमें स्टेट कैलकुलेट करनी है. तो हम क्या करेंगे, हम we will iterate over all nodes of we will iterate over all childs of node S. Okay, we will calculate all the states of child node U, right. After calculating the states, बेसिकली ये हम बस DFS लूप को कॉल कर रहे हैं. तो DFS लूप को कॉल करेंगे तो विद द मीन्स ऑफ रिकर्शन ये ऑलरेडी हमारी चाइल्ड नोड की, वंस वी विल बी आउट ऑफ दिस DFS लूप, इधर जब आएंगे ना हम, तो ऑलरेडी चाइल्ड नोड की स्टेट्स कैलकुलेटेड होंगी. नाउ वंस वी हैव द चाइल्ड स्टेट नोड्स, चाइल्ड स्टेट्स और डीपी स्टेट्स ऑफ चाइल्ड नोड, आर ओनली task is to merge these child states into our parent DP state. इसको कैसे करें? सिंपल है. क्या करेंगे कि हम हर एक DP स्टेट ऑफ पेरेंट को पकड़ेंगे, हर एक DP स्टेट ऑफ चाइल्ड को पकड़ेंगे और वी विल मर्ज देम. अब वो मर्ज कैसे करेंगे कि लेट्स से हमने चाइल्ड स्टेट की DP स्टेट्स, चाइल्ड नोड की स्टेट्स पर इटरेट किया, राइट. लेट्स से उसका सम है i, सम ऑफ द सबसेट इज i. और लेट्स से पेरेंट की भी स्टेट्स पर इटरेट किया. Here the sum of values of subsets mod k is j, right. So उन दोनों को अगर पिक कर रहे हैं हम, चाइल्ड में से एक सबसेट को पिक किया जिसका सम मोडुलो है i, पेरेंट में से पिक किया जिसका सम मोडुलो है j. इन दोनों को अगर कंबाइन करेंगे तो सम क्या होगा, i प्लस जे, और स्टेट क्या बनेगी कि i प्लस जे मोड की. और लेट्स से हम अगर कंसिडर नहीं कर रहे करंट नोड दैट इज एस नोड के, एस नोड को अगर कंसिडर नहीं कर रहे तो उस स्टेट में हम कैलकुलेट करेंगे स्टेट 0, राइट. उस 0 स्टेट में स्टोर करेंगे. और टोटल नंबर ऑफ वेज कितने होंगे? अब अगर हम करंट नोड को कंसिडर नहीं कर रहे तो हम चाइल्ड नोड को कंसिडर कर सकते हैं और नहीं भी कर सकते. तो बोथ वेज हम both ways we will take into account, right? So total number of ways क्या होंगे, dp of ui0 dp of ui1 into ये हो गए total number of ways to select a subset from child. अब total number of ways to select a subset from parent ये कितना होगा, dp of sj0. ये कैलकुलेट कर लिया हमने जीरोथ स्टेट, दैट इज वी हैव नॉट टेकन इनटू अकाउंट द वैल्यू ऑफ नोड एस. अगर हम वैल्यू ऑफ नोड एस को कंसिडर करते हैं, इस केस में क्या होगा कि अगर हमने वैल्यू ऑफ एस को कंसिडर कर लिया, इन दिस केस वी कैन नॉट कंसिडर द वैल्यू ऑफ चाइल्ड नोड. क्यों? क्योंकि अगर हमने कंसिडर कर लिया इन दिस केस ये एडजेसेंट नोड हो जाएंगे हमारे सबसेट में, ये हम नहीं चाहते. तो अगर हमने कंसिडर कर लिया value of node s, in this case our only possible number of ways to select a subset from child is this dp of ui0. और पेरेंट में से एक सबसेट सेलेक्ट करने के तरीके कितने हैं, सो दैट देयर सम मोडुलो इज j और value of node is s is selected, this is dp of sj1. So this is how we have merged these two states of parent and child, and after merging we will just assign the value to the parent itself and just return. This is how we are recursively calculating the states of all the child nodes to the parent and then root. So once we have calculated the value of all the states of root node, then our answer is simple. We can either take into account the node root node or do not take into account root node. And -1 is for removing the empty set, because in the question itself it is given that we need to take the empty set into account. So this was quite interesting and good problem. I hope you understood it. So this was all for this video. Thank you everyone. If you have any doubts related to this video tutorial, you may comment. I will try to answer. So thanks. Have a nice day.